Hello everybody, it is Caleb here, and I am back with another update of my Unreal Engine 5 lighting pack. The biggest update is that we are now in Unreal Engine 5.5.6, which comes with a much glossier, prettier lighting system that the DMX system can take advantage of. While we are resting our vision on this beautiful lighting system, I would like to take a minute to thank the Patreon supporters who have gotten me here. Eterno, Secret Meeting, Stephen Thompson, Maxime Roylo, Villeneuve, Aaron Sanchez, Endeavor, Tom Hill, Atsi TK, Imad Kais, Jesse Magana. It's a little dark over here. Let me add a light. There we go. We can always count on Asteratubes. 248, Stephen Thompson, Dini Agimba, Fatih Turkman, Dylan, Adam Jackson, Cuckoo Mail, and Beeb DJ. And of course, everybody who contributed up to the point of me making the Python executables that I'm still using today. Kendrick Feller, Eterno, Secret Meeting, Ton Huang, Sean Dog, Stephen Thompson, Oliver Elmers, Maxime Roylo, Villeneuve. Oliver, you're supposed to be on here. My bad, let me fix that. Oliver Elmers again, Maxime Roylo, Villeneuve, Igor Nikichenko, Endeavor, Matt Ford, Tom Hill, Atsi TK, Leo Palasola, Jesse Magana, MK Ultra, Imad Kais, and Aaron Sanchez. Thank you everybody for pushing this Unreal 5 project to a point where more people are using it. So let's go over some of these juicy details. As I said, we are now in Unreal Engine 5.6. That project is provided. The only setting that I forgot to do is go to project settings and type exposure, if I could spell, and turn auto exposure off. And then things look a lot better. We can use gobos with megalights, and the whole lighting system works with megalights. I remember that was broken in Unreal Engine 5.5. That is now working. So this is 5.6, and if you take a look at this clip, you'll see the exact same scene in Unreal Engine 5.5, which is a whole lot more grainy. So I do recommend upgrading to this project, unless of course you're in the middle of a production. And let's get into some of the other details. Aside from being in version 5.6, I have upgraded all multi-instance materials, reducing the textures to only 2 per fixture. This is 1 emissive texture call and 1 base color texture call. Currently, if we, and this lighting problem I'll fix where it gets too bright, but currently if we get close to the fixture, we can see all of its cells. If we get far away, there is a semi-layer of depth trick that happens where just a red or a white box multiplied by the color is drawn around the affected pixels. In addition, all of the multi-instance, or most of them, I think the ROX S2 still has the old system, but most of the multi-instance blueprints and their DMX profiles are upgraded to be a whole lot more compatible to changing attribute locations. So like if a master is on channel 2 of a fixture and it moves to channel 6, it will just read that channel or that attribute name as long as the attribute name stays the same. And this makes things a lot easier to read and modify in the blueprint. Also, some fixtures can generate their entire texture procedurally, which should improve performance by a bit. New fixtures are the Colorado Pixel Curve, the Sharpie X-Frame, and the Magic Blade FX. And then in addition, an update was made to the shutter table builder, which I kind of forgot to put in the pack. So if you're seeing this video, revisit that link and you'll be able to find that new shutter table builder exe. What this does is it fought an edge case scenario where I needed to select multiple channel functions in the GTF file in order to be able to use them to build the same data table. What was happening was some of the strobe functions were in one channel function, and the open functions or open effects were in a different channel function. In addition, a global head brightness for multi-instance fixtures has been added to the global parameters. So if you go to DMX Commons and look in parameter collection, what you'll find is global head brightness. And what this does is if you change it to like 0.1 or 0, it will remove, and these look red because they're just reflecting the light, but what's happening is the actual texture is not emitting anything. And what you might need to use this for is sometimes on like some people's lights, from what I've seen, is when you move them to Unreal Engine 5.6, some of them look very dark. So you might need to up this to like 2 or 10. It's there if you need it. It will be on all future releases. Hopefully it doesn't slow down performance by that much. Speaking of performance, it's still an issue that I'm fighting. It will always be an issue that I'm fighting. But I do currently have 16 frames a second with all of these lights going at once and all of their lights crossing over each other, which is decent. It could be better. I'm also only on an RTX 3070 card, so I consider that a good benchmark because a lot of you people are moving up to the RTX 4000 series, which obviously crunches pixels a lot faster. So let's get into a quick explanation of this new method that I brought about. Before, what I did was take a single pixel and illuminate it. From there, I would bake that texture into the UV map. From there, I would take the baked texture, and for instance 1, I would just place it in its original position. For every instance after that, I would offset the position by an X and Y value to eventually hit all of the pixels. And this is where a lot of the texture calls were coming from. That was in a blueprint that looked kind of like this. And if I were to offset them, I would get multiple pixels with individual color control. And I now illuminate all of the cells at once. I'll then bake an image of all of the illuminated cells in a blueprint that looks kind of like this. So the within range function, what it allowed me to do is draw between a certain X value and between a certain Y value that looked like the squares I just showed, and then multiply those textures together to create a block that represented where the light was coming from. So then I would have a texture of all of the pixels that I need with blocks drawn representing where the light comes from. Then I would multiply that by the actual pixel color, and I would get blocks of the instance colors that I need, of their appropriate DMX values. Then I would take that entire colored block image and just multiply it by the baked texture. And what I would get is a pretty looking, but still fairly efficient, colored correct image that is the exact same as calling the same texture 7 times, except now I'm only calling a texture once. Because of this one texture call for a 512 by 512 texture, I'm now only loading 262,000 pixels. And instructions are still needed to draw squares for every instance, but this still takes place on the GPU and not the CPU, and so it should make things a lot faster in the future. It's just a good foundational thing for me to have going forward. Previously, what I had for multi-instance fixtures that had a colored RGB matrix and a white matrix that were in separate locations is I had one block of dimmer channel matrices that held the footprint for the entire fixture. I also had an enumerator that held a list of all possible attributes that I could ever use. So this just had the names red, green, blue, amber. I did this to avoid typos, and also enumerators are faster than using strings. Then in the blueprint, I had an array of those enumerators that was essentially that fixture's DMX chart. In fact, and then I would get all of those, and I would have a switch on enumerator that could read those names, and each enumerator name was linked to an index number or the index order. That order corresponded with what the lighting console was sending. Problem with this, as you could see already, is that it was very confusing and blueprint heavy. It was also hard to work out 16-bit instances because I had to have a separate function for those to calculate the 16-bit value and normalize it. I also had to have different blueprints for every single operating mode. All this became a headache. What I do now, what I learned from Shandog, is that you can actually just type in a name on the DMX profile in the library and say this is white 1, white 2, white 3. And those white numbers correspond to what instance I'm talking about. And so for this reason, you can just move these around the DMX profile as needed if you're using slightly different fixtures, and it'll still work. On the left is the DMX profile, on the right is the array variable in the blueprint. And so all that has is a name, is a list of what names I'm looking for. It doesn't specify where those are in the DMX footprint. It just says what names I'm looking for. The DMX profile holds where those are in the footprint. What I do is first collect the data. So I get the master values for the entire fixture. And then I get the values per instance. So on the getting master values, I'm getting things like the dimmer, the master dimmer, the strobe duration, the strobe rate, any frost values. And then on the per instance, I'm iterating through all of my matrix cells that are just usually the red, green, blue values, and getting the normalized matrix cell values, making a color out of it, and then pushing that to my beam, light, and material. Separately, on a separate sequence, I'm getting all of the white values per cell. That's where I use my white array, because the white array just says I'm looking for this attribute name, white 1 through white 16. In the incoming DMX library that it's going to receive, it will find those white 1 through white 16 values no matter what channel they're on. Once I collect those values, then I can push those to the beam, light, and material. Let's take a sneak peek at what's happening in the August update. July was a lot of foundational updates to improve performance and usability. Frankly, a little boring. There was a couple cool things like the new fixtures, but in August we're going to get some flashy new toys. Prism component is added and done. That works for beam fixtures and for spot fixtures. Working with that prism fixture, I realized I had a need to now rotate the gobo texture in the material instead of just updating the entire beam lens assembly. So that's added. Strobe functions have been expanded and upgraded to look a lot better. Currently, the strobe functions that Epic ships frankly don't look that good. And so some new strobe functions have been added. The scripts have been updated. And then, like I said, gobos can now rotate in their own texture without rotating the entire beam, lens, or spot assembly. Updates to all of the scripts have been added, enabling live DMX input instead of reading a GDTF file. What you can do now, if you don't have a GDTF file is connect your DMX and then run the script and start it up in the live DMX capture mode. As long as you're sending ArtNet from your lighting console, you can just cycle through all of the attributes that you need to record and capture their live DMX input and still build the data table that you need automatically without having to punch in all those values manually. That is it. Thank you everybody for tuning in, and I hope to continue growing with you. I know this project's moving progressively forward. It's a little slow. There's only one of me. But thanks for tuning in, and I hope to talk to some of y'all this next month about some of these new updates and other world of DMX stuff. Thank you, everybody.